So yesterday, as you're about to see, I went down to the Mirror Ball in Blackpool. It was the 9th of December. The sun had already set, and I was trying to do a nighttime observation of Walney Lighthouse. Now, from this particular location, we had quite the distance. So this time it was 19 miles of an observation. So, let's look at some of the statistics for this particular observation. This is the tide heights for Blackpool yesterday. So 9th of December 2019, we had low tide at 15:31, and it was just after 5 p.m. when I actually took the observation down from the beach. And at that exact time, if we scroll down here, you'll see that at 17:04, the height of the tide, which had turned and was starting to come in, was at 3 meters and 37. Now, it's come to my attention from the previous video that I did that the focal height of the lighthouse above sea level is actually above sea level at high tide, and that's at high spring tide and the average of such. So what I'm going to do for this particular video is include that. So the height of the light has to be adjusted now, and we need to include this in this particular calculation. So we've got 3 meters and 37 was the height of the tide when I was filming. We have a high tide of essentially 6 meters or so higher than that. So let's go to the calculator, and what we're going to do is we've already put that in meters to feet. So we have 6 meters is equivalent to essentially 19.5 feet. Let's round it up and say 20 feet. So the height of the lighthouse where we saw the light is 19 feet plus the focal height given of Walney Lighthouse. Now, what is that? So Walney Lighthouse is 69 feet to the focal point of the light. So 69 feet plus 20 feet is 89 feet. Let's call it 90 feet. Let's round it up and say 90 feet. So when I was down on the beach, the height of this Walney Lighthouse here, this focal point here, was 90 feet above the actual sea level when I took this observation. So let's have a look at the Blackpool historic swell charts for yesterday. So we are looking for Monday the 9th, and we have a swell between 3 feet and 2 feet, and that will be the average. But obviously we know that 1 in 7 of these will be slightly higher. But just for argument's sake, I'm just going to say 2 feet there or thereabouts. We also had an incredibly strong wind that was blowing. You'll actually hear that in the video too. That will be wind-driven waves too, chop on top of the swell. Now, it's worth taking this into account because when I place my feet next to the shoreline and I set my tripod up, my tripod and camera may be 5 or 6 feet above actual sea level at that time. Well, actual sea level at the shoreline. But it isn't actual sea level out to sea, because we also would need to realise that the sea is moving up and down, and that is moving the hard deck of the ocean to points where in certain locations you can get many meters of risen height due to this movement of the sea. As it so happens in this particular case, if we just say that the height of the waves was 2 feet, and that would include the trough to the peak, we are looking at 1 foot of physical blockage by the movement of the ocean at the very least. So if I claim that my feet and my camera is set to no more than 6 feet above sea level, essentially we can lower that down to 5 feet because the ocean itself is rising up and causing a blockage in the distance. So here is the Mirror Ball in Blackpool. This is the Mirror Ball. When I was filming the Mirror Ball and I was filming from the top of the ramp, I was right here on the corner at the top of the ramp. I actually then went down this ramp, had to negotiate this trough of water that was down at the bottom because there was no access down there, so I had to actually scale down these concrete circular things down here. Very tricky, had to navigate down there to avoid going through this water. Anyway, once I did that and I walked directly out to this location here, this is where I set my tripod up. The water was no more than 20 meters or so from me, which was around about here. Let's put the water line in there. That would be where the water line was. This is where my tripod was set up. And what we're going to do now is do a measurement as to how far it would be from this location here to Walney Lighthouse. 18.9 miles. That would be the distance as the crow flies to Walney Lighthouse. If we put this into an Earth curve calculator, what we come up with is 18.9 miles distance to the lighthouse, viewer height in feet, no more than 5, no more than 5, 5 is being generous. We have a geometric hidden of 174 feet. Bearing in mind the focal point of the lighthouse is only 90 feet above actual sea level. That would place it 84 feet hidden geometrically. Now then, if you are one of these people that believes that light can refract around the sphere Earth, when we include refraction, which in my opinion is absolute nonsense, however, it is something that the globe earthers believe, with refraction, it would say that 145 feet should be hidden. Now that's knocking off nearly 30 feet from the geometric. So it is saying that with refraction, 145 feet, and yet that still isn't enough to get down to the 90 feet of where this focal point of the lighthouse is. That's a big problem for the globers. A very, very big problem. Lastly, I want to show you a couple of still shots. Now, this is a still shot that I took, which had a very clear image of the actual flash from one of these flashes on the lighthouse. You can see the water waves here, and you can see it carries on. You can see a very spherical shape on the light source. Let's go to the next image. Now what I've done here is I have put a line in. I was able to adjust the contrast and the colour of the observation, and to the best of my abilities I was able to put a line in as where I actually visualise the top of the water waves, and that is clearly below the centre of the light source, the centre of the light source. So there's all the information. Obviously we can see that there is a huge problem if we see the lighthouse, which obviously you'll imagine that indeed we do. It really doesn't matter how far we keep pushing these things back, how far we keep going away. One thing is for sure, we see far further than we should do if we live on a sphere. And let me put this into context. This geometric size of the Earth is the globe Earth. Let me clear this off. Is the globe Earth calculation to get this sphere, right? Now then, if you look at this sphere that we are supposed to live on, you'll notice there is an awful lot of water. An awful lot of water. And the reason that it has a sphere, the reason that it comes into a sphere, is that apparently gravity from the centre of the Earth is pulling the water towards it. By means of this gravitational pull, it creates a perfect sphere. Slightly maybe bulbous at the middle, if you believe that we're spinning as well, like so. However, the simple facts are that the water must curve. That's it. It has to curve. The minute that the calculation is broken, the minute this shape and this size is no longer accurate, the minute that this calculation breaks down is when this doesn't become reality. So with all those things, I guess it's time to play the video so that you guys can see what actually happened. I imagine it's no small surprise to anybody that obviously we see the lighthouse. Okay, so it is murky and it is really dark looking over towards Walney Lighthouse from essentially about 45-50 feet above sea level. But we can actually see it flashing 19 miles away, so I'm going to go down to the beach to about 6 feet above actual sea level. It's really choppy, really quite windy, it's very murky. I don't know what the results are going to be, I honestly don't know. But I'm going to give it a go and let's see if we can see it at such a long distance. Hey! Well, what do you know? We're seeing the lighthouse from no more than 6 feet in elevation, no more. The tripod is only set to 3.5 feet. And I'm only around about 20 meters away from the water. So this is less than 6 feet elevation at 19 miles away. Walney Lighthouse, even with the chop, and the wind is howling. You know, it's 18-mile-an-hour winds right now, and we've got some big waves, and we're still seeing Walney Lighthouse. It's undeniable. Where's the earth curve? Where is this water that's curving? Where is this water that's curving at 76R? So that we can see this lighthouse. Where's the light? How are we seeing this light? That lighthouse should be gone by tens of meters. Tens of meters. Houses high should be lost to earth curve. Yet we're seeing this. It was never really in any doubt, really, was it? Let's be honest. Let's be honest. Let me show you my location.